Hello, in this video we're going to talk through problems number 63 and 64 from the review packet. These are two acid-base titration problems. So we've got these. Let's probably do problem number 63. What is the molarity of a sodium hydroxide solution if 38 mL of solution is needed to neutralize 14 mL of 0.75 molar sulfuric acid? So first thing we need to do is to write out a balanced chemical equation. It gives us a hint right there above. Write out my balanced chemical equation. So sodium hydroxide. Sodium has a +1 charge. Hydroxide has a -1 charge. So my chemical formula is just going to be NaOH. Sulfuric acid, I am given the chemical formula. This is an acid-base neutralization reaction. So this is one of those double displacement ones, we call it. So the hydrogen and sodium are going to switch places with each other. The hydrogen is going to stick with hydroxide, forming water, okay? And the sodium is going to pair with the sulfate. This is our salt. When you're looking at the salt, you have to consider the charges to figure out what the subscripts are going to be here. So sodium, when I look over the periodic table, I see it's a +1 charge. Sulfate has a -2 charge. So when I do my crisscross method, the 2 comes down here. The 1, we just don't write the 1. So this is my chemical equation. If I stop and do my T-chart, I'm going to notice that it is not balanced. So I'm going to count my sodiums, hydroxides, hydrogens, sulfates. We'll just show, like, for example, over here we have 1 sodium on the left, but 2 sodiums on the right. So to balance it, I need to put a 2 right here. Now that gives us 2 hydroxides over here, but only 1 right there. So let's put a 2 here. And then if I stop and count, I will see that everything is now balanced. Hooray. Okay. So all that is getting my balanced chemical equation. Have to do that first. Then we can start dealing with the numbers and try and do a titration calculation here. So when you're doing a titration calculation, just like any kind of stoichiometry problem, so this is basically stoichiometry, right? We're doing some calculations involving a chemical reaction. The first step is always going to be find moles. So what do I have information to find moles about? Well, I've got a volume and a molarity of my acid. So since molarity is moles per liter, I can say that moles is molarity times liters. So if I know the molarity and the volume, I can figure out moles. So my molarity of sulfuric acid is 0.75. My liters is 0.014. I have to divide my milliliters by 1,000. So if I stop and plug that in my calculator, I've got 0.75 times 0.014. It looks like I have 0.0105 moles of H2SO4. Alright, so that's step 1, find moles. Now I'm trying to find, this is moles of H2SO4, I'm trying to find molarity of NaOH. So my next step is going to be convert from moles of acid to moles of base. So this is my mole ratio step. I'm going to scroll over here. So I'm starting with moles H2SO4. So whatever units I have go on the bottom of the fraction. The units that I want, which is moles NaOH, are going to go on the top. And I look at my balanced chemical equation. It looks like it's a 2-to-1 ratio. So 2 sodium hydroxides for every 1 H2SO4. So when I plug that in my calculator, that means that I had 0.02 moles of NaOH. That's step 2, convert from moles of acid to moles base, or vice versa. And then the last step is going to be to use my molarity equation again to solve for molarity of sodium hydroxide. So my moles of sodium hydroxide is 0.021. I'm using my answer from this previous step. The volume of sodium hydroxide, let me go back to the question, it looks like 38 milliliters. Notice how there's 2 volumes, 38 and 14, so make sure you use the right volume. So I'm trying to find molarity of sodium hydroxide, use the volume of sodium hydroxide, not the volume of the acid. So this is 0.038, because we got to convert it into liters. So our milliliters divided by 1,000 gives you liters. And so divided by 0.038, my molarity is 0.55. Okay, let's try one more here. So I've got calcium hydroxide, and HNO3. So first step, like before, is to write out a balanced chemical equation. Whoops, I wrote H twice. Okay, so the first elements are going to switch places with each other. So H is going to combine with OH. They always combine in a 1-to-1 ratio. That makes water. And you can write either way. I don't care if you write HOH or H2O, whatever is easier for you. And then the calcium is going to go with the nitrate. And I'm going to look here at the charges. Calcium has a +2 charge. Nitrate's -1. So if I do the crisscross, the 1 goes down here. We don't write the 1. 2 goes down here. Wait, that looks like 32, so let's put parentheses here. Okay, I'm going to go back and I'm going to cross this out. So here's my reactants and products, and when I go through and balance it, I will find that I need a 2 here and a 2 here. Alright, so let's now do the calculations bit of it. First step is always going to be find moles. So it looks like I have a volume and a molarity right here, and I know that moles equals molarity times volume. So my molarity is 0.014 molar. My volume has to be in liters, so I have to divide my milliliters by 1,000. So I'm going to stop and plug this in. 0.014 times 0.0142. My moles is 0.000199 moles of HNO3. So that's step 1. Step 2 is I'm going to convert this 0.000199, it's a lot to write out, moles of acid, and I'm going to try and convert it into moles of base, because that's what I'm trying to figure out is my calcium hydroxide. So the units that I have go on the bottom, so moles HNO3 go on the bottom. What I want goes on the top, moles calcium hydroxide. And if we look at my balanced chemical equation, looks like it's 1 calcium hydroxide for every 2 HNO3. I get those from the coefficients right here in the chemical equation. If there's nothing written, that we assume that means 1. Okay, so let's go back down here. So I've got basically half as much calcium hydroxide, so that's 0.0000994 moles of calcium hydroxide. And then my last step is I'm going to use my molarity equation again, which again, you don't have to memorize this equation. It's on your formula sheet. Make sure you're looking at the formula sheet so you are familiar with everything that is on there, so you know what you're given and what you need to memorize. You don't need to memorize really much of anything. So I'm going to take my moles, 0.0000994 moles, and I'm going to divide it by my volume, and that's my volume. Got to make sure you use the right volume. It's your volume of calcium hydroxide, 0.0246, and we find that the molarity is 0.004 molar. Alright, so that's problem 63 and 64.